I didn't even show this. So, cut. All right, new break here. Remember before we use 3 equations like these, and then I'm going to test out adding 2 more here in this video, just to emphasize that we can get a better fit by more data values. So that's where we're at, and then this is what I wanted to talk about, was this right here. So using matrix operations on exactly 3 points, and then we're talking about a quadratic where you only have A, B, and C. You only have three unknowns. And if we have exactly 3 points, we could do it by the least squares. But here's one thing: using matrix operation is the same as solving a system equation by substitution or elimination, which is what we did before using the matrix, and we'd use the reduced row echelon form to solve that system. So with more than 3 points, it's implying using a method of least squares. Find a best fit parabola. So what we're talking about here is regression. I think hopefully I'll be able to show this in a matrix form, but we'll see. So just working on this as we go. And like if as we go on through here, then here's greater than, using more than 3 points produced a best fit equation that minimizes overall error. So we should get a closer fit here. And then I went ahead and asked it another question: what if I add more data points? Again, shifts the process from simply solving a system to performing a quadratic regression using the least squares method. And as it says, this is fundamentally more robust and generally considered more accurate for real-world scenarios. And you can do this with or without a matrix. I'll show you the statistical method a little bit on it. So, all right. So, more data, mo better. That's the big point. And so what I'm going to get to here I did 4. And we're going to keep going up as we go on here. So now let me just show you what happens using the 4. And I believe I have that in a Desmos. So in the Desmos, notice I established what A was, right? And remember, this is what we're looking for. This is adding these data points over here. Added the 40 and added 50. And you can see we're calculating them the same way. And now we have 5, 1, 2, 3, 14, 2, 36, 130, 33. So I only added 1 here. I'll go ahead and add in this other one. The 40, I don't have the 40 yet, but that's what I'll get to here in a moment. But anyway, these are the operations. A transpose times A transpose times B. And that comes from solving a system of matrices. Let's see if we can bring up the squared method. Here's where the equation ends up. So what it is matrix. It's a matrix linear system. As we've seen, matrix are systems. So trying to make this a long story short, but anyway, we can find those values by using this equation. That's where this equation comes from. Let me go over here, and I hate to ruin it, but let's try another Desmos. And see if I can get this to do what I want to do. Go into the matrix calculator. Let's do a new matrix. And I'm just going to show you what a transpose is right now. No, actually, let me go with what we're going to go for here. And I'm going to record all of these. So I need a, looking at my pages here, we need a 5x3. So we'll go over here. Always indicated by 5, and then 3. So we have 5x3 here, and here we go again. 4 2 2 5 4 9 0 0. Oh, that's the inverse. So here we go. 4 2 5 4900 900 2500. And there was something else, the 2500. And then there was a 1600. Okay, there we go. 65, and then we put in a 1 for the C, so all these C's would be 1. And here we go. We need the 4900 will be 26 point. Oh, that's the X value is 70. The X value on the 900 is 30. The X value on the next one is 2500 would be 50. And the X value for the 1600 is 40. All right, so I got all those. So let me show you what an A transpose is, and you'll see this in Excel, basically switching X's and Y's. So here we go, A transpose. See that? How we just simply, well, I guess we'd say X's and Y's, we should say rows and columns. Notice now my columns are rows, right? And rows are columns. That's what a transpose is. So that's the first thing you want to do is multiply by A. But I think I said something about they have to be square matrices. And see that A transpose times A did give us a square matrix. Notice it's now a 3x3. It has to do with multiplying. I don't want to get too much into matrices. I just want to show you that as you mo data, mo beta, right? Mo data, mo better. And I want to get the inverse of this, and that's a weird thing that they say, but basically it's multiplying finding the matrix that can be multiplied by another matrix to get the identity matrix, which is basically all zeros except for ones down the line. So anyway, that's what this is. So we'll take it to the -1. That's our inverse of that. Now we got to multiply it by, there's one other thing I need to do. I need to create a new matrix. Is the B matrix. So the B matrix is a column matrix with all the Y values associated with these values. And just a reminder, this is where I'm getting that data from. See, I got them a little bit out of order, 4900, 70. These are all the X values. Then we got 40 on the bottom, but we got, and then it doesn't matter the order either. Doesn't matter the order. And so what we've got to do is put what they each equal. So it would be that first one, 30.5. That second one, which is known as 70, would be 26.1. This 900 leading coefficient 1 is 14.2. And the 50 is 33.2. I need one more row, right? I need 5 rows. And the 1600 one is 25.8. So now we'll go down here. Go down to this part. So now we need to multiply A transpose. Let's bring that other thing up here. There we go. A transpose times the matrix B. And then there we have it. And there we have our coefficients, A, B, and C. So now let's bring in Desmo. Okay, so I got all these in here. I just did that one. Let me get rid of that one. Let me get rid of all these. And all we're comparing is this one right here, which we calculated before using 3 values. This one will use 4, so it would be x squared plus 3.4708 x plus or minus 61.7785. So it became purple. What's interesting is by using, let's turn off the old one. Let's turn off the, okay, so again, I just want to point out that this was the one we did with 3 values. This was the one that took all the values in account and was created by Desmos. And then we got this one right here by using 3 points, the purple one, or 4 points. So this could be getting better. I mean, if you notice it, we were here with 3 points, and then we went down here with 4. And notice that it's kind of jumping around. So now let's go and see what we could do manually to calculate the linear regression line and see if we get any closer. We're going to use all 10 points this time. So we're going to continue this mo data, mo better stuff. And as you can see, originally these were the 4 or 5 equations that we had. Now we're going to add in equation 6, equation 7, equation 8, 9, and 10. That means all the data points we really had. In my data set, I had 10 data points. And one thing we're going to do here, that's what we added. We added these x values here into each one of these. And as you can see, here are the x values added: 25, 35, 45, 75, and 55. Can't drive 55. So we're going to add those in to our matrices and see how that works out. Okay, so I couldn't get Desmos to do it, but I want to see how this works. So this is going to be definitely an adventure. So let's look at let's start with our top equations. Okay, so I went into Scientific Notebook and I did that separately because it's old and it freezes up. But I was able to get this document prepared where we're solving for, as you can see here, the 10 equations put into what we would call the matrix A, which is just simply chopping off the y values. So there we go. Now let me just, now that we got that, so now we have the matrix A, we initiate the function to transpose, which is interchanging rows and columns, which we have here. And then we establish matrix B, which is simply a column matrix with all 10 of the equal sign parts, and I'll show you what I mean here. Ooh, there we go. See, 30.5, 26, 14.1, right? These are all what is on the other side of the equal sign. So we'll keep those things in mind. So now let's calculate that first part of the calculation here, A transpose times A. Remember, this is A, this is the transpose, and order matters. So it's got to be A transpose times A. So here you see A transpose being multiplied by A, and then here we have the conclusion, and then we want to inverse it. So now we inverse it, and then we end up over here with this matrix right here, which is A transpose times A inverse. Now the other part of the equation we need is A transpose B. So here we have right here A transpose B. I established what B was. A transpose B, here we're taking A transpose times the B, and here we got this 3-row, 1-column matrix. Now we've got to take both of these times each other, right? So let's do that next. And here it is. We take our value over here, which is A transpose A, -1 or inverse, and we take it times A transpose B. And then here we have it. Here we have our new numbers. So now let's go back over here into Desmos. Remember, this was with the 3 points. This was with the 4, and the blue is with the Desmos using the quadratic equation. So now let's put in our new values here. -0, -0.03142 x squared, plus now the b value 3.4583 x, and then the c value -61.497. And it made it red, which I don't necessarily like, but let's black this one out. That was with 3 values. The purple was with 4, and now this new one is right here. So maybe this new one in the red is a better fit, but you got a lot of things going on with it. But notice that it is closer to the quadratic what was derived. What was derived. See how much closer, and then let me turn this one off. See, that was with 3 points. This was with 4. And here we have with 10. And notice how close it is to the actual regression. So Desmos used something similar to this. They may have used statistics method, which I'm going to do next. Alright, we're going to try to get this quadratic model going here, and I'm just going to break it down in the most simplest possible titles here, X and Y. And then we also need a column for X squared. We need one for X to the third. We need one for X to the fourth. We need an X times Y. And we need an X squared. Oh, let's just do it this way, X squared, just to make sure we got it. X squared times Y. Alright, let's bold all these. Make them a different color so it stand out from the other stuff we're doing here. Okay. And so let's put in our X's. This is the same data that I've been working with before. Just putting it in here. And over here are our Y's. Alright. So now we need to square, and I'm using Excel, so let me try to zoom. So we're using Excel. So to put in a formula, put equals, and then we want to square this one. Alright, we should be able to copy all of that down here. You can see those are the X squared terms, right? Now let's do X to the third. We'll do it the same way. This one to the power 3. Let's copy that down. Let's copy that down. Let me just make sure I'm in the right thing. And then over here we've got equals X to the power 4. We got that, so we'll copy that down. Is it just XY? Let me double check. I don't do this all the time. So it's X. Oh, so first we need XY, so that would be this one times this one right here. And then now let's just copy that down. And by the way, you see some pretty big numbers there, but it's going to go to scientific, and that's perfectly fine. We know what scientific means. So now what we want is X squared, this one right here, times Y. And now let's copy and paste that down. Alright. So now we want to sum each column. We want to sum each column, and we should be able to do this down here. Let's just put sum, and I'm going to use the sum function here in Excel. I'm going to use the sum function here in Excel. I may not have hit. Yeah, I did, so L12 maybe. There, we got it. I bet I can get sums on all of these by dragging over. And it appears to be. We have been able to do that, as this is summing O2 to O12. We got those. Alright. Now let's pause a moment here. Okay, so I just wanted to show this, and what they're going for here is we're going to have a system of equations, and they will be oriented in this way. So one thing is n. N should be, and I'm going to simply put it in as 10. Hey John, this is John from the future. That's where you made your big mistake. N is actually 11. You went back and forth from this data right here and this one here a couple of times, and you're confusing with these 10 values. There was actually 11 originally. Notice there is no 60 in any of these, so there you go. That's where your error occurred, but I remember. You figured it out. In my if I end up using Excel, I'm not exactly sure how I'm going to demonstrate what I'm trying to do here, but let's go back here. It's a work in progress. But anyway, what we're trying to do is create these three equations based upon these sum totals. So as you can see, the first would be n times. Maybe I can write it out. Let's try our equation here. Let's try our equation. We just got to split our screen a little bit here and go over here. So if n equals 10, then I'm just going to write this as a text. So it would be 10a, and then it would be the sum of the x's.
Would be right here. So let's change this, move that over here. We need the sum of the x's. There we go. Hopefully I got them all in. So that would be the next one. The next row would be 550b, indicating sum of x's. And then over here, it would be the sum of the x squareds, which is right there, 30250, and then that would be c. And then what it's going to be equal to would be the sum of the y's. So let's sum those up, which I forgot to do, and I'm in the wrong place for that. My bad. Oh, Excel, I hate you, Excel. Here we go. Now, what was I doing? The sum of the y's, and then you go over here, sum these up. Sorry, I shouldn't badmouth Excel. It just, when I get stuck on stuff, it's very frustrating. So that would be 275.51 for the first equation. And remember, this is like an equal. Let me make sure this is an equal here. Yeah, so I knew it was going to do that. So let me put the equal in this one just so we see what we're talking about here. And then this would be the 275.51. That would be our first equation. Our second one would be the sum of x's, 550a, and then the sum of the x squareds, 30250b, and then the third one would be the sum of the x cubes, which is 1787500. Then it would be the sum of the, and that's times c, and then we're going to equal it to what we have over here, which would be the sum of the x's and the y's, which is right there, 14648.8. Let's separate this one out so we see what we're doing. And I'm just going to put, yeah, that's fine. And then the next one, the third one would be the sum of the x squareds, which is 30250, sum of the x squareds, times a, what we're doing right here. And then the sum of the x to the thirds, which is right there, 1787500. B, and then the sum of the x to the fourth, which is 14648.8. C, and then that will be equal to the sum of the x squared y's, which is right here, 828089. And there are our equations.
There are our equations. And luckily, by the way, let's copy that, put it over here. Show what we're doing here, and then there are equations, and this file will be available if you want to look at it. So all those things being said, let's not use Scientific Notebook because I'm afraid it's going to freeze while we're trying to record a video. But one thing we can do here is bring up Desmos. Let's get rid of that one. Get rid of that one. I was trying all sorts and I couldn't get too many there to deal with 10 variables. So now let's put in our matrix here. New matrix. This time it's going to be a 3 by 4. And here we put in our numbers. We got 10. We got 550. We got 30250. 3 by 4. Oh, I put it, there we go. And then 275.51, 550A, 30250B, 1787512, 14648.8, 3025, 1787500, 14648.8, 828089er. Now let's see if we can get it here. So there are our new equations. John from the future again, John. N equals 11. So after working on it a few times over using different programs, but anyway, I'm making a long story short, and here you see my eureka moment, and you see changing that small change got us to the correct answer. Alright, so here's the moment. I don't know what kind of moment it is. I'm getting pretty tired. It's 1 a.m. Saturday. I just was down that once I found that N was not 10 and N was 11, I was inspired to finish these videos. So that's what's going on right now. So anyway, just as a reminder, remember the red one was when we used 3 points, and then the light blue one here is the quadratic regression, and then here is the one where we used 10 points, the 10 points. And you can see how it's gotten closer to the regression. And so now here we're going to put in what we have over here, right? Those are our new coefficients, only it's inverted, and I can't quite, there's a couple different ways you can do this. You could invert this and this matrix the other way, but anyway, the way this is going to be read is 0.031494 x squared, and then in the middle plus 3.4669, and then negative 61.692. And it's got us, does it give us another blue? Ah. But look how close we have gotten here. Wow. That one is right on top. Definitely Eureka, y'all. Definitely Eureka, y'all. It's because it, there we go, Eureka for sure. But as you can see, that one using the model, the statistic way, using the table and the sums, and then creating a 3x4 matrix, which we can reduce row echelon and solve it. The only thing I think,
so one thing is that I'm trying to point out, and I hate that when I did this recording, my little picture there was in the lower left. But what I'm trying to emphasize here is that so we went from 4 points to 10 points to 11 points, and the 11 nailed what the computer in Desmos was doing. We did it by hand.
Rough draft, where we were talking about 10. How could you get it to fit better? Okay. And then let me make one other note here. So to make the by hand calculations better, started off with 3, then we did 4, then we did 10, and then we just did 11, right? With my big mistake there, and then we're really, really close. So therefore, we have exactly what I was trying to prove with these videos. But yeah, that's what I was looking at. Look at how close these numbers are. Almost dead on with what the regression is. And we would get closer and closer to what Desmos was doing. But we're dead on with that last method. So to answer that question, there you go. Alright, it looks like we finally got to the end of these videos here on the project. But I do want to bring up the final question. Let me get myself oriented. There we go. Ah, there we go. Okay. If we look at this, so we just did this one. That's the big one. And you don't have to do all the detailed steps. I just wanted to show you the process and how you get closer and closer, and also how thankful we should all be for technology like Desmos that does these regression lines in a snap, right? And then I wanted to point out about this particular one, the 10-part D. Based on your work with these tasks, what cautions would you give someone when making decisions based on quadratic models? So watching all of that video, I think that would help answer, and I'll leave that up for you to answer that question on your own in your paper, and I'll be looking forward to seeing your thoughts. So long.